Hello and welcome to GED Mathematics Live at PALS. In this video, we will be talking about equations and inequalities. In these lessons, we will look into solving linear equations, solving inequalities, graphing inequalities, and writing equations and inequalities. One of the biggest topics in algebra is solving equations and inequalities. Both come in many forms, but the goal always remains the same. Find values that make the given statement true. In fact, that is exactly what it means to solve for x. In this lesson, you will study the most common types of equations you will see on the GED test. Let's start with linear equations. What is a linear equation? The difference between a linear equations and a linear expression is just an equal sign. Technically, a linear equation is a linear expression set equal to a number or equal to another linear expressions. To solve any linear equation, the goal is to get a statement of the form the variable equals to a number. Again, the final form is the variable equals to a number. And in order to do this, any operation that has been applied to the variable must be undone. The one rule to remember is that any operation performed on one side of the equation must be performed on the other side of the equation as well. With one-step equations, only one operation is being done to the variable. This means that it takes only one step to undo this operation and get the final answer, the variable by itself. Let's try an example. One-step equations. X minus 4 is equals to 14. So to undo minus 11 is by adding 11 on both sides. So minus 11 plus 11 is equals to 0. So we only have x on one side, and 14 plus 11 is 25 on the other side. So x is equals to 25. Another example, 5x is equals to 15. Okay, the operation is 5 times x multiplication. So to undo multiplication, we can divide both sides by 5. So 5x divided by 5 is 1, and 15 divided by 5 is 3. So x is equals to 3. Now another one is 2x. Another one is 2 over 3x is equals to 8, or 2/3 x is equals to 8. Now this is a multiplication, and to undo multiplication, we can divide both sides by 2 over 3. So 2/3 x divided by 2/3 is equals to 8 divided by 2/3. Then simplifying the answer, we've got 24 over 2, which is equals to 12. Now, the work in the third example may seem complicated, but remember that dividing by a fraction is the same as multiplying by its reciprocal. On the left, 2/3 divided by itself is 1. Any number divided by itself is 1. And 8 divided by 2/3 is, by definition, 8 times 3 over 2. So the overall process of undoing the operation still held true. Now let's proceed to two-step equations. As you might guess, in two-step equation, two operations are being done to the variable that you must undo before you can find its value. At At this stage, I want you to take note of the methods, but the order of the step is important. Okay, step 1, undo any addition or subtraction first. Step 2, undo any multiplication or division. Okay, let's try an example. 4x minus 1. So there are two operations, minus 1 and subtraction and multiplication. So we can undo the subtraction first by adding both sides by 1. So we have 4x is equals to 8. Then undo the multiplication. We have x is equals to 2. Okay, another example. X over 7 plus 3 is equals to negative 5. So first, let's undo the addition by subtracting both sides. So we have x over 7 plus 3 minus 3 and negative 5 minus 3. We've got x over 7 is equals to negative 8. Then to undo division, we can multiply both sides by 7. So we have x is equals to negative 56. Now let's proceed to multi-step equations. Some linear equations have variables on both sides of the equation or have unsimplified expression on one or both sides. In these situations, the equation has to be simplified before you can apply the usual process of undoing operation. Now, I want you to take note of the following steps. Step 1, simplify one or both sides. Step 2, bring all the variables to one side of the equation. Step 3, undo any addition or subtraction. Step 4, undo any multiplication. So let's try an example. 3 times x minus 6 plus 1 is equals to negative 2. So solve for x. Before you can move terms, you need to simplify the left side using the distributive property. So we can multiply 3 times x, which is 3x, and 3 times negative 6 is negative 18 plus 1 is equals to negative 2. Then simplify, we have 3x minus 17 is equals to negative 2. And then undo the negative 17 by adding 17. So we have 3x is equals to 15. Then dividing both sides by 3, we've got x is equals to 5. Another example. 4x minus 9 is equals to 5x plus 1. Both sides are simplified, so you can start off by moving terms around. So bring all the variables to one side. We have minus x minus 9 is equals to 1. Undo the subtraction by adding 9. So we've got negative x is equals to 10. Undoing the multiplication by dividing both sides by negative 1, x is equals to negative 10. Okay, another example for multi-step equation is 2 times x plus 3 is equals to 4x minus 1. First, simplify by using the distributive property on the left side of the equation, and then you can move the terms to get the excess on one side. So we have 2x plus 6 equals to 4x minus 5. Then moving all the excess on one side, we have negative 2x plus 6 is equals to negative 1. And then undoing the addition, we have negative 2x is equals to negative 7. Undoing the multiplication, we've got x is equals to 7 over 2. Let's proceed to solving inequalities. So far, the only type of relationship you have seen between two expressions or terms is equality, as shown in an equation. However, it is possible that two expressions relate in such a way that one side is smaller than the other, or vice versa. This type of relationship is called inequality. Okay? And to solve inequality, the steps in solving linear inequality are exactly the same as those used in solving linear equations. There is, however, one very important new rule to follow. Anytime you multiply or divide by a negative number, the inequality changes direction. Let's start with an example to show how this works. Again, anytime you multiply or divide by a negative number, the inequality changes direction. So let's try negative 4x is greater than or equal to 16. So in order to undo the multiplication, we need to divide both sides by negative 4. However, because this is negative number, the direction of the inequality will change. So undoing the multiplication, and the direction of the inequality changes as well, as you can see. So the answer is x is less than or equal to negative 4. Let's try another example. X minus 5 is less than 2. So first undo the subtraction by adding both sides by 5. So we have x is less than 7. Another example, 2x minus 2 is less than or equal to negative 10. Undoing the negative 2 by adding 2 on both sides, we have 2x is less than or equal to negative 8. Dividing both sides by 2, we have x is less than or equal to negative 4. Now let's proceed to graphing solutions, especially the solution for linear inequalities. Using the number line, all of the values of x that make a given inequality true can be shown by shading the region representing those numbers. In this process, an open circle, remember, is used if the inequality uses less than or greater than, while a closed circle is used if the inequality uses a less than or equal or greater than or equal. Let's try an example. Negative 3x plus 7 is greater than negative 2. So first, undo the addition. So we minus both sides by minus 7. Then we have negative 3x is greater than negative 9. Then we undo by dividing negative 3 on both sides. But since we are dividing negative 3, so we need to change the direction of the inequality symbol. So we have x is less than 3. Now using a number line, we can plot the graph. Since x is less than 3, so we draw an open circle on 3 and draw a line from that open circle down because the values of x are any number less than 3. Now let's see some more example of graphs for linear inequalities. Okay, x is greater than 2. So open circle, then drawing a line, shading a line to the right of the number 2, because the values of x are any numbers greater than 2. Then x is less than or equal to negative 1. So we shade the circle because x is also equals to -1, and drawing a line, an arrow going to the left side of the number line, because x are any numbers less than -1 or equal to -1. Okay, another one, x is greater than or equal to 4. The graph is a close shaded circle, then an arrow line moving to the right. Lastly, let's proceed to writing linear equations and inequalities. But before we proceed with examples, let us be familiarized with some symbol and key phrases. Okay, symbol equal, the key phrases that signifies equal is the same as, equals, was, yields, gives. For less than is less than, is smaller than. For the third symbol is less than or equal to, is the same or less, is the same or smaller, at most. Then the fourth symbol is greater than, is larger than. Then the last symbol is greater than or equal to, is the same or more, is the same or greater, at least. Okay, let's try an example. Okay, Mary's age in years is 3 more than Blake's age. If Blake's age is B years and Mary's age is M years, write an equation that represents Mary's age in terms of Blake's age. So Mary's age is 3 more than Blake's age. So the statement implies that if you add 3 to Blake's age, you will have Mary's age. So therefore, the equation is m is equals to b plus 3. M represents Mary's age and b represents Blake's age. Another example, Bob makes it a rule never to let the balance in his bank account drop below $100. If the balance in his bank account is D dollars, write an equation or inequality to represent his rule about the balance. So the balance should be D is greater than or equal to 100. Why? Because his rule says never to let the balance in his bank account drop below 100. So it could be 100 or it could be more, but not below 100. It should be D is greater than or equal to 100. Another example is a warehouse will only accept crates that weight under 500 pounds. If a crate weighs C pounds, write an inequality that represents this requirement. So the phrase under is the same as less than. So therefore, the weight of the crate should be C is less than 500. It should be less than 500. Another and last example is, in terms of employees, the accounting department of a company is 3 times as large as the marketing department. If the number of employees in the accounting department is A and the number of employees in the marketing department is M, write an equation to represent this relationship. So 3 times as large means that you would have to multiply the number of employees in the marketing department by 3. So to get the number of employees in the accounting department, as an equation, this can be written as A for accounting department is equals to 3 times M, or M represents marketing department. So A is equals to 3M. Okay, that's the end of this video. If you have any question, or if you did not understand parts of the presentation, you can comment below. If you want to know more about Phuket PALS, you can visit www.phuketpals.org, or you can contact us to our Facebook, Phuket PALS, or you can call us on 081 417 0978.